Okay, welcome everyone to our second session
Is
of,
Jay
uh,
Lieberman here?
of our discussion on science and religion. The focus today is going to be, or this evening, is going to be on the question, is there a God? We covered some of the first few slides here last time, so I will go through them rather quickly. But I want to get into the meat of it, and there is a lot of material. So here we go. So first, as I always think it's very important to do that, the reason that we haven't had to go through the issues and details of asking you to pay for these classes is that my role as the community rabbi for the Jewish Federation of Ventura County is made possible by Joel and Barbara Aronson through the Affordable Living Choices Trust. And I am very grateful for their support. And if you want to express thanks for the support of the Federation on my webpage, and you can just go to jewishventuracounty.org and make a contribution there. As I will announce every time, I do keep copies of materials and also videos of these sessions on my website. If you simply go to lotger.com, hopefully you'll see the new website, which looks something like this. It's a little confusing because sometimes you'll find your way to the old one, but actually, well, the only new postings will be on the new one. So you can see the slides for these classes, a bibliography, and some significant quotes on science and religion on the website. And then the video of session 1 is on the website. And late this evening, early tomorrow, I will have video of tonight's session. It's also posted on the videos are also posted on my YouTube channel. And I will send out a little email thanking you for participating and also giving you access to the video in that way. So to review where we were last time, and the way I look at the question of faith and science, and I think most of you know me, know that I am a scientist. I have undergraduate and graduate degrees in physics. I worked most of my first career in the alternative energy business. I was president of a wind power development company, put up projects in Southern California and in Hawaii. And I worked for several energy companies, including 2 Israeli energy companies. So I have a science background. My brain thinks like a scientist, but clearly also I'm a religious man. I am a rabbi. So how do I understand faith and belief and science and logic in these 2 worlds? That's really the focus and substance of this entire course. But for me, at least, belief and faith comes down to 2 key leaps. Leap number 1, is there a God? And by God, I mean an organizing intelligence behind the creation of the universe. And I'm going to say, let's call this God Elohim. I'll mention a little more about that in a moment. That's leap of faith number 1. So there, and that's the subject of the discussion this evening. This discussion of this evening will really focus on the question, what is the evidence for God's existence? Leap number 2 is, does God care? And I always use these 2 examples. You can make up your own. Does God care whether I have turkey or ham for dinner? Namely, ritual kinds of issues. And does God care whether I am kind to or torture babies? Ethical issues. That's, for me, a separate leap of faith. One of the interesting things that in Jewish thought, there are 2 words that we commonly see both in the prayer books and in the Bible about God, 2 names for God, if you will. One is Elohim, and one is Adonai. Adonai is really a word which means my Lord. We say it in place of God's actual name, Yud-He, Vav-He. And in rabbinic tradition, God's aspect of justice is associated with the word Elohim. Elohim can also mean judge. And God's aspect of mercy is associated with Hashem or Adonai. And there's lots of interesting reasons for that. But I find it also interesting that it kind of lines up behind the two leaps of faith for me. And even the two stories of creation in the book of Genesis. The first one is really almost more of a scientific description of what's going on in the heavens and earth and creations of different species and the seas and dry land and wetland and dry land and seas and planets and so on. That is sort of more of a science-based description. And then we're in the Garden of Eden, and it's very personal. We meet Adam, we meet Chava, we meet the serpent. We have personal interactions. And a God who apparently is intimately involved in their lives. So that's my frame of reference for talking about these kinds of matters. So the question then becomes, can we prove God exists? So although some would say yes, and here's a very interesting book by Robert Spitzer called New Proofs for the Existence of God, I would say if someone, let me back up, I would say if we could prove God's existence, someone would have done that by now, and this would not be, a matter of discussion and controversy. But even before we get into it, what do we mean by God? For purposes of this discussion, at least what I mean is something intimately associated with the God that I worship, which is the God of Abraham. Danny Matt, who is the leading authority on Kabbalah and the Zohar, describes God as the name we give to the oneness of all. Trying to fix God in a particular image and saying, okay, this is the God we're talking about. And oh, by the way, this is the reason why I don't believe in this God. Here's the God I'm talking about, an old man sitting on a throne in heaven somewhere. I don't believe in that because that's silly. Well, I agree with you. I don't believe in that God either. Fixing God into sort of a narrow set of boundaries is what we mean by idolatry. For now, for purposes of this discussion and leap of faith number one, I will use organizing intelligence in the universe. Many would call this the intelligent designer. And the intelligent design as a movement has come to be associated with fundamentalist Christianity. So I'm a little resistant to use that language, but I would say an organizing intelligence in the universe.
Rabbi?
Yes.
When you refer to universe, are you talking about everything out there or that which revolves around our sun?
No, when I say the word universe, I mean everything. I may not always be precise, but that's what I mean. If I'm talking about stuff revolving around the sun, I would say solar system.
Okay.
So for purposes of tonight's discussion, I don't mean a God who hears and answers prayer and who micromanages the world. That's part of leap number two, and that's the subject for next time. So yeah, so I said this. If we could prove God's existence, someone would have done that. So the question is, what's the evidence? And I showed this last time, and I'm not going to go through it again. You can look at the video. If you're interested, I think it's well worth looking at. So a lot of what I'm going to talk about tonight really refers to the fine-tuning of the universe and the fine-tuning of life. And what I mean by that is there are lots of laws in physics which have the form of a mathematical expression, but then you've got to plug in a number. So for example, I'll just take the gravitational force. Gravity says that if I have two masses in space somewhere, or even in your house, they have an attractive force, and the force of their attraction is equal to the mass of object number one and the mass of times the mass of object number two divided by the square of the distance between them. So if they're further apart, it's a reduced force. If they're close together, it's an increased force. times a number. That number is called G. And it's a big number. If the number was much bigger than the one that we have now, we'd all gain some weight. If it was much less than the one we have now, we would all lose some weight. But as you'll see in this discussion, almost every law of physics as we understand it today has some kind of constant. And the value of the constant is critical, because if you change it slightly, then the universe looks very, very different. And I will be introducing this idea of an anthropomorphic universe. What do I mean by an anthropomorphic universe? A universe that could support and sustain life. So for example, just to give you an idea where I'm going, if the force of gravity was much less, was much reduced, then stars wouldn't form because the atoms wouldn't coalesce into a sun. Without stars, you wouldn't have anything progressing beyond hydrogen. The way the heavier elements are made is that under the force and heat of the cores of stars, elements combine in something called nuclear fusion, and heavier elements are created. So in a bunch of examples, and you'll see specifics on this, if you tweak these numbers a little bit, you have a very uninteresting universe, which is only hydrogen. If the force of gravity becomes a little bit greater, then all the hydrogen might be combined into making heavier elements, and there's no hydrogen. Or the Big Bang would be followed fairly quickly by a big crunch. So what you see on the screen in front of you are examples of four basic kinds of forces. The strong nuclear force is the force that holds atoms together. Okay, back to high school physics or chemistry. You have opposite charges. I'm now talking about the electromagnetic force. You have positive charges and negative charges. So the nucleus of an atom has protons positively charged and neutrons not charged at all. And whizzing around the atom are electrons negatively charged. Positives and negatives attract each other. If I have two positive charges, they repel each other. So once again, it's a good thing that the nucleus attracts the electrons. Otherwise, the electrons would just fly off and we'd have no atoms. We would have a state of matter called a plasma. But now think about the nucleus. Inside the nucleus, I have a bunch of protons. They're all positively charged and they are very close to each other, which means that electromagnetic force is greatly repulsive. The nucleus wants to fly apart. Fortunately for the universe, there's a countervailing force called the strong nuclear force. The other thing which is very important, and I will get into this a little bit, is the initial conditions at the Big Bang. And we'll see actually some quotes, I think, from Stephen Hawking on this. If you change some of the initial conditions, the temperature and so on of the Big Bang, again, you have a very interesting universe. So I'll comment on a question. Could you have an organizing intelligence without that intelligence emanating from some kind of physical entity? Yeah, I'm making no claim about whether the organizing intelligence is from a physical entity, but it is from an intelligent, namely a deliberate entity. I would say that's what I would say is part of this belief. Whether God has a physical body is something that I'm not sure. I definitely don't want to go there tonight. Okay, so it's not only the numbers themselves, but in some cases, the ratios of these numbers. So not only the absolute value of some of these numbers, but for example, the ratio, well, you'll see in the next slide. So here's the ratio of the electromagnetic force. That's the force holding the protons and electrons together to form an atom, divided by the force of gravity. And it's either a numerator or denominator, whichever place you want to put it, but it's 1 followed by 36 zeros. If you had a few less zeros, you would have a short-lived mini universe, no time for evolution. Another ratio is easy to remember. It's 007, 0.007. It's the fraction of energy released when hydrogen fuses to form helium. Basically, what's going on in hydrogen bombs and in the sun and in every star, and is really the factory of the universe, is hydrogen atoms fuse and join together, and they create helium, and they liberate some energy. That number, how much energy they liberate, tells us what the strength of the bond is that forms helium. If I go from 007 to 006, the entire universe is hydrogen. Namely, there's no fusion. So there's nothing interesting going on, and the entire universe is only hydrogen. It's not an interesting universe at all. There's no other atoms, there's no water, there's no chemistry, there is no nothing. There's no further fusion. Stars don't have any energy. We have a thin vacuum in the universe and nothing else. If that number is a bit higher, namely instead of 006 and 008 to 008, then there's no hydrogen. All the hydrogen in the stars would fuse to form helium. Now, why is hydrogen important? Well, our life form is based on what we call hydrocarbons, namely carbon atoms and water. Water's H2O. So hydrogen is at the heart of the chemistry that makes up life as we understand it. Maybe there would be other life forms. That's a possibility. But life as we understand it requires hydrogen. So no water. And again, another small change in this would eliminate most of the carbon from the universe. So again, in some of my recent readings in the book Myers, which I introduced last time, I came across another number which I was unaware of. As we delve deeper and deeper and deeper into the world of atomic physics and subatomic physics, we find, that stuff is made up of molecules. Molecules are made up of atoms. Atoms are made up of particles. We have protons, neutrons, electrons, and so on. And then as we start digging into what makes up those elementary particles, we come up with something called quarks. And there are different kinds of quarks, up quarks and down quarks. And this author points out that the masses of the quarks had to have been simultaneously met 9 different conditions in the early universe. This is what I mean when I talk about the early, the status of things shortly after the Big Bang. Their masses must have a value between 0 and 1 billionth trillionth of the Planck mass. Planck mass is a fundamental unit of mass, which is a fine tuning in the part of 1 part in 10 to the 27th power. Now, I haven't figured out how to do scientific notation in PowerPoint. I should work on it more. I probably could figure it out. So this would be 1 part in a number. How big is that number? 1 followed by 27 zeros. In the same way, the gravitational constant, which I mentioned, is also fine-tuned to 1 part in 1 followed by 35 zeros. Meaning, if the number is more or less, the universe is fundamentally different and not hospitable to life. Now, I want to talk about, this is per Robert Spitzer, and also amplify on a point that I've had some discussion with my friend Bryce on. So Spitzer takes there's about 20 fundamental constants of the kind that I've been discussing. And he says, this actually is, Spitzer's quoting someone else's proof. He said, how many different possible possibilities are there in these 20 variables? And he says the number of different possibilities are 1 part in 10 to the 10th to the 132nd power. And that's an enormously high number. The number of zeros in that number would be more than the number of atoms in the universe, which is 10 to the 65th power, and even more than the number of elementary particles in the universe, 10 to the 80th power. So it's an enormously unlikely combination that gives us the universe that we find ourselves in. Now, one of the things, Bryce sent me an interesting paper, I guess a couple of months ago, which says we really can't talk about this odds because we don't really have anything to compare it with. And having thought about that a lot, I think it's an issue of terminology. I'm not certain about that. But even if I set aside the question of odds, it's just there's a lot of different possibilities, more possibilities than there are atoms in the universe. And we find ourselves in the one where life exists and where we have a stable universe producing lots and lots of different atoms. Okay, so again, some more quotes from Stephen Hawking, who is a noted atheist, from his book, Black Holes and Baby Universes and Other Essays, a collection of essays by Stephen Hawking, a very interesting book. He says, if the density of the universe 1 second after the Big Bang had been greater than 1 part in 1,000 billion, billion is 9 zeros, 1,000 is 3 zeros, so that's 1 part in 10 to the 12th, the universe would have recollapsed after 10 years. On the other hand, if the density of the universe at that time had been less by the same amount, the universe would have been essentially empty since it was about 10 years old. All my work, quoting from another page, all my work, says Stephen Hawking, has shown that you don't have to say that is the way the universe began. I'm sorry, that you don't have to say that the way the universe began was the personal whim of God, but you still have the question, why does the universe bother to exist? If you like, you can define God to be the answer to that question. Hawking has an interesting issue, like many scientists, after the Big Bang has been confirmed, and the Big Bang actually was a name given to the theory of the way we now understand the universe began, which was given as a term of derision, I think by Fred Hoyle. The problem with it is, although it seems to comport nicely with the Bible's description of, Bereshit bara Elohim, in the beginning God created the heavens and the earth, it's problematic, I would guess, for the scientific mind. So many scientists have had a problem with that, but we're stuck with the evidence for the Big Bang. Stephen Hawking came up with, I think, an interesting mathematical tool, and I don't have the foggiest idea what this mathematical tool means, but he said, if you assert that there's a possibility of something called imaginary time, then you can show, at least mathematically, that the universe had no beginning. When he uses the term imaginary here, he means something very specific. Forgive me if I'm taking some of you back to horrible memories of high school and college algebra and maybe calculus. You remember the square root. The square root is a number when multiplied by itself gives you another number. So the square root of 4 is 2. 2 times 2 is 4. The square root of 1 is 1. 1 times 1 is 1. Calculus defines a number I, which is the square root of -1, which says that I times I equals -1. But it's not positive and it's not negative, because a positive times a positive is a positive, and a negative times a negative is a positive. So we have this thing called imaginary numbers, and I believe they are useful in some electrical engineering functions. Stephen Hawking proposes a concept called imaginary time. I'm just going to glance at the notes. A universe with many areas where fundamental constants vary, avoid the problem of uniqueness at the initial. Yeah, but we still find ourselves in this universe. And there's lots of combinations, only one of which can result in the universe we find ourselves with.
Well, if you look at the very next one,
Yeah, and the next one is really what you said. It's a tautology. We can't find ourselves in a universe that won't allow us to exist. So that is the anthropic principle, as you correctly point out. So the question is, as we examine the sum of conditions required to bring us into this universe, do we just say, anthropic principle, you know, what am I having for dinner? Or do we say, wow, something amazing is going on here? Whether we calculate it as a probability or simply call it something amazing and remarkable, I will leave to others. But for me, it is amazing and remarkable. Continuing with Hawking, commenting on the Big Bang evidence, it would be very difficult to explain why the universe should have begun in just this way, except as the act of a God who intended to beings like us. I probably left out a word there. And another quote, the remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. I think I used this slide last time. Forgive me if I'm repeating myself. But Fred Hoyle, who's the astronomer who coined the term Big Bang, and remember, he coined the term Big Bang because he was deriding the concept of the Big Bang, early in his writing says, religion is but a desperate attempt to find an escape from the truly dreadful situation in which we find ourselves. No wonder then that many people feel the need for some belief that gives them the sense of security. And no wonder that they become very angry with people like me who say that this is illusory. And then after his work in fine-tuning, basically in cosmic background, it's in the background radiation, which proved the Big Bang, he says, a common sense interpretation of the facts suggests that a super intellect has monkeyed with the physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion beyond question. And yeah, so Jay makes the point that another answer to this is infinite universes. And as you read the literature, you find discussion of this. The problem with infinite universes as a physics theory is that it is by definition untestable. As I understand science and physics, if you're going to have a theory, in order for it to be a valid theory, it should explain the data you know about, and then ideally it should predict some experiment by which you can say, okay, if the experiment goes this way, my theory is confirmed. If the experiment goes this way, then my theory is worthless. That's a theory. By definition, as I understand infinite universes, and I've been reading carefully on this, they are definitionally undetectable. So it's as though I say, the reason there is gravity is that there's invisible little springs connected to everything, and they're undetectable, and they behave, you know, according to the laws that the same physics of gravity, but that's really what's going on. There are little springs, but you can't detect them. That's not physics. I would say that's mythology. So I want to move on to other evidence. And, you know, Bryce, I'll just comment on the thought that the universe might fine-tune itself. I don't know what that means. Self-organized, again, I don't know what that means. Or that there's no such gravity, the whole earth sucks. That I know what it means. Okay. Evidence for God's existence. Some more interesting things that we find now that we have a universe. Let's take a look at this universe. And specifically, let's take a look at our little corner of the universe. And this, you can tell the age of this slide because Pluto of blessed memory returns as a planet. So the shape of the Earth's orbit is interesting. I think I even have some details on this. Orbits, according to, I think this is Copernicus and Newton, are ellipses. And ellipses can be fairly oblong, or they can be very circular. Technically, what we're describing is so-called the eccentricity of an ellipse. The Earth has by far the most circular orbit in our solar system. And if the Earth's orbit were as I can't remember the word now. If it were as squished as the next most circular orbit, then we would be alternating between moments when, or seasons, when all the water on Earth would freeze and all the water on Earth would boil. Not very hospitable for life. And then also, I think this may be in a later note, Earth is just at the right place where we have this zone of liquid, frozen, and gaseous water. And that zone is only a tiny fraction of our solar system. The structure of the water molecule is also very interesting. As you all know, and this picture illustrates, ice floats. Ice floats because when water freezes, it expands. Most materials in liquid form, when they freeze, they contract and sink. So think about wax. If you have, if you heat up a jar of wax, the molten wax will be on top and the solid wax will be on the bottom. What's the significance here for life? The significance is frozen lakes where you have lakes in cold climates, the surface freezes. This not only allows the invention of ice skating, but it also provides a thermal shield for the muck and the creepy crawly things that are developing underneath at the bottom of the lake. And then there's even a more technically interesting element about the structure of water. And this is the most mathematical slide I will show this evening. Again, for most materials, as you cool them, they get heavier in density. So here's water temperature, in degrees Celsius. As it cools, the density goes up, it gets heavier and heavier. And you know this if you jump into a pool or a lake, as you go down toward the bottom, it gets colder and colder. You've experienced this? I'm looking at your faces now. So nod if you've experienced that. Yes. And I even noticed that if I have a glass of or a bottle of water in the car and it's gotten warm, the water at the bottom is definitely cooler than the water at the top. That's true of water, but water has a very odd and significant aspect to this, or unexplainable aspect, and that is it reaches a maximum density at about 4 degrees Celsius, or about 42 degrees or so, or 40 degrees Fahrenheit. So what that means is, again, think about this pond. The colder and colder water is sinking and sinking and sinking until we get to about 40 degrees F. And at the bottom of the pond, which is now protected by ice, at the very bottom of the pond, you're going to have 40 degrees water, which again allows life to continue rather than having the entire pond frozen over. And Bryce says life as we know it, and yeah, I mean life on the Earth. My friend Robert Piccioni, who I hope is here. Robert, if you're here, you can chime in and say hello. Has written a couple of books which are very interesting on these subjects. One is this one, and they reference atoms, Einstein, and the universe. And another one, from which I quote a lot, called "Can Life Be Merely an Accident?" And Robert's a PhD physicist who lives in Westlake Village, and I've gotten to know him in lots of different ways. And he comes out, or he sort of highlights in a wonderfully elegant presentation, which he calls the Goldilocks Zone. So what he's talking about is how we find ourselves where things are just right in the universe. So, for example, our galaxy is the Milky Way. It's one of many, many galaxies. Pretty ordinary galaxy. But one of the nice things about where our galaxy is compared to the center of the universe, where the Big Bang took place, is we are sort of on the outskirts. So we're not subject to a lot of the flares and emissions and radiation that you find more central in the universe. We are also in the suburbs of our galaxy. We're kind of out on one of the wings. And once again, if we happen to be located more centrally to our own galaxy, we would be subjected to enormous amounts of radiation from explosions and things, which would prohibit life as we know it to exist. The type of star that our sun is, by the way, the fact that it's a single star, only about a third of the stars that we know about are single stars. Most stars are binary or even more than two stars orbiting each other. And those of us that read some science fiction, usually you can find a story about living on a planet where there's a binary star. That may look pretty cool, but in fact, if you have two stars orbiting each other and you're sitting at some sort of fixed distance, the amount of energy you're getting from these stars is going to vary greatly and destabilizing sort of orderly evolution. We actually have some very nice planetary neighbors, one of which is Jupiter. Jupiter's mass is, I think, more than double the mass of all the other planets in the solar system. And the fact that we have this big brother out there, Jupiter, one of the effects of having this huge mass sitting where it does is to clear out a lot of the asteroids and other pieces of floating junk that would otherwise be routinely impinging upon us. And I'm not talking about burned out Chinese rockets. Our moon is a very interesting entity.
Rabbi?
Yes.
I was just reminded, was it 1994, the Shoemaker-Levy comet crashed into Jupiter? I remember seeing
Yeah,
photos.
I was out of town, so I missed that.
Yeah, I think I can Google that.
Okay, yeah, but
So
that
that's
has
definitely protection.
Yeah,
Well,
I don't know if the gravitational, if it would have crashed into the Earth. I'm really more talking about the evolution of the solar system.
Well, one of the problems with Jupiter also is that Jupiter destabilizes a lot of comets and not really comets, but a lot of asteroids and things like that. And they end up becoming Earth-crossing asteroids. So it's a double-edged sword.
Yeah, but so far it's working well. But one time when it didn't work was in the creation of the moon, when a object crashed into the Earth and created the moon, our satellite. And the moon, the size of the moon as a satellite, I think, as you may well know, maybe you don't know, other planets have lots of moons. As our system of astronomy has developed, I mean, you can with a decent telescope see moons of Jupiter and Saturn, and then as you know, as we've gotten much more sophisticated, there are lots of moons orbiting these planets. The Earth's moon is far, far larger in comparison to the Earth than any of these other moons. The collision that created the moon had some implications of melting the Earth at the time, having the iron sink into the center of the Earth and creating, I think I have a slide on this, a significant magnetic field, much more powerful than other planets. The moon's effect in orbiting the Earth stabilizes the spinning of the Earth. You know, if you've seen a top and you spin a top, you know it wobbles. The technical term is precessing. But the fact that the moon is circling the Earth and it has such huge mass stabilizes the spinning of the Earth and stabilizes the seasons by keeping the Earth's axis pretty much the same. We have evidence, if you go way back in history of the Earth, that the Earth's axis has flipped, but certainly not I think not since the beginning of significant life on Earth. Again, all of these seem to have been chosen to allow life on the planet. So just some more details. Yeah, some of these things that I mentioned. Positioned in the galaxy far enough to avoid radiation and colliding stars, but close enough to the center to have carbon, oxygen, and so on, because those elements were made in the fairly early stages of the universe. I mentioned about being a binary star. The luminosity is very stable, like 3% variation over the last 600 million years, not so common. I mentioned Jupiter. I mentioned our magnetic field, 100 times larger than other planets. The magnetic field protects the atmosphere. I have a slide on that, from erosion. And we're in this 1/100,000th section of the solar system where we have liquid water. So here's a picture of me. What did you do on your vacation? Well, I went to Churchill, Manitoba to see the Northern Lights. And it's about 30 or 40 degrees below zero. And by the way, when it's that temperature, C and F really don't matter. But what you're actually seeing is the effect of our magnetic field. The Earth's magnetic field is like a bar magnet going through the Earth. And what it does is it deflects the solar wind. The sun is putting out, I just read this today in Bob's book, I think it's like 100 million tons of solar wind every day or every hour. I just can't remember. And the magnetic field of the Earth deflects that toward the poles rather than allowing it to impinge on the planet. When it gets deflected toward the poles, it enters the atmosphere, and the combination of the magnetism and these particles, these charged particles striking atoms in the atmosphere, result in what we call the aurora borealis, or the northern lights. If we didn't have, if our magnetic field was similar to Mars, for example, the solar wind would gradually just strip out all of the atmosphere of the Earth, and that's what astronomers understand happened to the atmosphere of Mars.
Well, one of the problems we have with this magnetic field, though, Rabbi, is that it flips. It changes. The North Pole will become the South Magnetic Pole, and while it's in the state of flipping, and it's not instantaneous, all of that stuff can come down. You're going to have a lot of extinctions when that happens.
It's possible. The question is whether we will have an atmosphere after it happens. And
we do, because it flips. The Earth's, it flips. It's flipped many, many, many times over Earth's history, and we still have an atmosphere.
Yeah. So if we didn't have that magnetic field, we wouldn't be having this discussion, because we'd have no atmosphere and there'd be no life on Earth beyond maybe some lichen or other things that can survive with very low atmosphere. A whole other category has to do with life itself. So now the interesting thing is life and DNA develops almost immediately with the cooling of the Earth. So the technical question, the scientific question is the creation of DNA, which is a highly complex structure, an accident, or is it guided somehow? And in mentioning this, we've known since 1953 what the structure of DNA is, but to date, we haven't been able to produce a single molecule of DNA in the laboratory, knowing all the elements we need, knowing, having control over pressure and electrical impulses and so on. So the question is, what's the probability, what's the likelihood that this happened by random chance? And this is Dr. Piccioni's book, Can Life Be Merely an Accident? And he has what I think is a brilliant way of describing the probability of actually a much less complex molecule than human DNA being developed as quickly, appearing anywhere in the universe, not just on Earth, appearing anywhere in the universe as quickly as it did. And he discusses this in units of pulling aces. So if you pull an ace, if I fan out a deck of cards, and I'm not a magician, believe me, I'm not an Egyptian or a magician, and I say pick out the ace of spades and get it right the first time, the probability of your doing that is 1 in 52. Everybody with me? Looking for nods? Yes. I say too easy. Do it twice in a row. To do it twice in a row without making a mistake is 1 in 52 squared. 1 in 52 times 52, or 1 in 2,704. Too easy. Do it 5 times in a row without making a mistake. The odds of getting that right is 1 in 380 million, sorry. So what Dr. Piccioni reports is the odds that actually a simpler molecule than DNA, I reread the book today, was created spontaneously in the 13 billion years of the universe's existence, is equivalent to pulling that ace 119,000 times in a row. That's the issue of the problem of how does life begin at all? And then we have another question, which I have to admit, I just started reading in Meyer's book, which is the issue of, now that I have life, the way we understand life in terms of natural selection and Darwin is basically you have simple forms of life, and then through spontaneous mutations or mutations caused by radiation, maybe when the, when the magnetic poles flip or something, changes are made in the animals and its DNA. And if those changes happen to help it survive, natural selection takes it to the next level. So as a perfect example of this, in England, there was a species of bird, I don't remember what species of bird, but it was white. And that helped it survive from, protected from its enemies in the winter when there was snowfall. Great. Now along comes the Industrial Revolution. And in much of England, you had factories just churning out soot. So having those white birds wasn't so helpful anymore. And pretty quickly, we started seeing in the same species of bird, black colored ones. So we seem to adapt to the stresses of life. The question that Myers raises, and I'm just beginning to understand this, is basically what DNA is a long word, a very long word, with a lot of information coded in that word. Basically, he starts a whole discussion of treating it as though in a similar way that it's a computer code. And it is, it's a computer-like code for continuing life. So everything, as I think you know, everything in a human comes from the DNA in an egg and a sperm. Everything that's coded to make that life a fully human life is coded in the DNA. Now the question is, suppose you randomly change some of those molecules. What's the likelihood that you get something useful? And what he points out, and I have no way of judging this, so I'm just quoting what he wrote. For every one DNA sequence that generates a short protein fold of just 150 amino acids in length, there are 10 to the 77th non-functional combinations. This, maybe explaining it as an English word, is another way of looking at this. For every meaningful sequence of English characters 12 letters long, there are 100 trillion gibberish combinations 12 letters long. It's like a combination lock with 14 dials of 10 digits. So think about it this way. If I give you a sentence and I start saying, we're going to change some random letters into other letters, what's the likelihood that we will come up with something intelligible? Darwin explains the survival of the fittest, but not the arrival of the fittest, how they are formed in the first place. But I will have to confess, my learning in this area is continuing. I don't fully understand it.
Rabbi, I think this is a specious argument because the the process of evolution does make random changes, but natural selection selects the ones that work.
Right.
Right?
No,
And it takes place over a very long time, and this kind of argument is easily demolished.
well, I would say it's not easily demolished when you look at the likelihood of useful random changes and as quickly as they happen. There's something called the Cambrian shale explosion.
Yes, yes, exactly. The Burgess
And
shale.
what the Burgess shale. And
Yeah.
what happened in the Burgess shale was at one point in time, life exploded. And so what he does, and I won't try and reproduce his analysis, is he looks at the likelihood that useful changes could all happen so quickly, given the complexity of these molecules. And I am not competent to call it rubbish or call it brilliant, except it's there and it's from a respected source.
And
Having said that, having said that, let me ask if there are other comments that people would like to offer.
I just think kudos to Bryce for saying specious when discussing species.
Yes, you can write a book, Bryce, called The Origin of Species. So having said that, I am absolutely a believer in evolution. Evolution explains too much to disregard it. And what I would say is evolution is God's tool for creation. So in Genesis, in 1:26, God says, let us make humanity in our image. So it's very interesting because God is speaking in the first person plural. God often, in fact, it's only in these Genesis stories that God speaks in the first person plural. Usually God speaks in the first person singular. I am the Lord thy God who took you out of Egypt to be your God. So the question is, what's going on here by saying, God, let us make humanity in our image? People have suggested that God was speaking in the royal we, as you see the Queen of England speaking in formal pronouncements. But in most of the text, God speaks first person singular. The traditional Jewish answer to this is that God was speaking to the heavenly host, his angels and other characters with God, the seraphim and others in the heavens, and God is speaking to them. You can guess what the traditional Christian answer is, that God was speaking to himself as a Trinity, Father, Son, and Holy Spirit. An answer that I've seen recently is, which I really like, is that God was talking to the animals. And really, God was talking to the rest of creation. This quote is on the 6th day of creation. Everything else has been made, according to the first chapter of Genesis. So God says to creation, okay, together we will make humanity. I like this. I think it's a biblical proof text for evolution. My bottom line, the evidence convinces me that something is going on here. To suggest that there's nothing going on here, I think begs the meaning of language. Another quote from Abraham Isaac Cook, who was the chief rabbi of Palestine, and then became the chief rabbi of Israel when Israel became a state. And he says, the theory of evolution accords with the secrets of Kabbalah better than any other theory. Evolution follows a path of ascent and thus provides the world with a basis for optimism. How can one despair, seeing that everything evolves and ascends? When we penetrate the inner nation of evolution, we find divinity illumined in perfect clarity. Ein Sof generates, actualizes potential infinity. Again, this is quoted by Danny Matt in his book on Kabbalah. Some more quotes from a physicist, Arno Penzias. Astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying, one might say, supernatural plan. From Fred Hoyle, who we quoted before. life arising through random chemical reactions was as likely as the assemblage of a 747 by a tornado whirling through a junkyard. Copernicus, so vast without any question is the divine handiwork of the Almighty Creator. I think this is the same quote that I quoted from Hawking before. Freeman Dyson, the more I examine the universe and the details of its architecture, the more evidence I find that the universe is in some sense must have known we are coming. And then astrophysicist Robert Jastrow, at this moment, forgive me if I quoted this last time, at this moment it seems as though science will never be able to raise the curtain on the mystery of creation. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. And for Maimonides, the very rationalist Jewish philosopher, the only path to knowing God is through the study of science. And for that reason, the Bible opens with a description of creation. So some final thoughts on this. I believe the evidence for an organizing intelligence is overwhelming. The key question is not belief in God, but how does belief in God affect our lives? Let me clarify. Most people, when asked, say they believe in God. I would also say most people, when asked, my experience in doing this with smaller groups, I ask people, do you believe in the North Pole? And the answer is, sure, I believe in the North Pole. There's an axis upon which the Earth spins, and the northern, point of that axis is the North Pole. And then my question is, how does your belief in the North Pole affect your life? And the answer is probably not very much. Then the question becomes the same question about God. The question is, how does belief in God affect your life? Or is God as abstract as a belief in the North Pole? Another element which comes up a lot in these discussions is the question of uncertainty and free will. And before quantum mechanics, this would be a real issue, I would say, for scientists, theologians. And the issue is the following. If you were God and you could know the exact position and movement of every particle in the universe, if that were knowable, then the prediction of what will happen forever is fixed. Think of it as like, billiard balls on a table. You know a ball is going this way at this speed and this momentum at this in this location. You know what it will do, and a really good billiards player can run the table. So the resolution of this comes up in quantum mechanics in the Heisenberg uncertainty principle, which asserts that you cannot know the position and the momentum. Momentum is a combination of velocity and direction of any particle with more than a certain level of precision. And it's not a question of getting a better instrument. It's that the measuring process itself introduces some uncertainty. And let me give you at least the explanation that makes sense to me. Suppose I have a tiny little thing like an electron, and I'm trying to figure out where it is, or maybe another particle, and I'm trying to figure out where this thing is. Well, how do I do that? It's too small for an optical microscope, so I use an electron microscope. Namely, I'm going to bounce electrons off of this little object, and where it bounces back, kind of like radar, that will tell me where the thing is. But if it's really, really tiny, every time I bounce something on it, it's going to be affected by the thing that just hit it. So there's an inherent lack of precision built into the structure of matter. And taken to its extreme, that ultimately makes the future inherently unpredictable. Another element, this for me is an inspiration I take from quantum mechanics, and that is reading the Bible, reading the Torah. You probably know that traditional fundamentalists of every stripe, and that's in the Jewish world and in the non-Jewish world, read the Bible as though it is the literal word of God. So that's one way to read the Bible. I am certainly not in that camp. I read the Bible as though it's inspired by something, and we're going to talk a lot more about revolution, maybe revolution, about revelation and Torah and scripture next time. I like to read the Bible not only as if it's the word of God, but also as a scholar would read it, namely, where did these stories come from? How were they developed? How were they influenced by the cultures that wrote them? So you can answer which one is the true meaning. And I like the tension between them. So, and I look to quantum mechanics and wave-particle duality for an inspiration here. For certain experiments, light acts as if it is a wave. If I take a crystal, a prism, and hold it up to the light and see it split into a bunch of colors, the way I explain that is by understanding that light is a wave, and I can do the physics and I can understand why white light gets split into its component colors. On the other hand, if I have a calculator here, and my calculator has a photovoltaic cell, and I look into some of the details about how the photovoltaic cell works, the way a photocell works is inexplicable if you assume that light is a wave and a wave only. If I assume light is a particle and the energy levels are quantized, that's where we get the name quantum mechanics, then I can explain the operation of a photocell. So if something as basic as light needs two ways of looking at it to capture its essence, to me, that's an inspiration for Torah. The books behind me, some of them are very, very traditional. And as I read Torah, as though it is the literal word of God, I am blown away, amazed, and inspired by the lessons that I find there. And so I love to look at very, very traditional interpretations of Torah, where a spelling error wouldn't be considered an error, but it would be considered as a message that God is trying to give us. On the other hand, I also like to read it through the eyes of people like Thomas Elliott Friedman, who you'll see it more from a scholarly point of view. Let's see if I have. Okay, so that, it's a little after 8. I'm going to stop sharing, and I am going to move you guys back so I can see you very well. And I can bring my chat down to this other screen. Whoops. And so if you want to keep posing things into chat, I can see the chat. But now, so I'll keep recording. If people have comments or questions or discussions, I'll entertain those. And at some point, as people are starting to leave now, I'll end the recording and just hang around as long as people want to continue to talk. So you are probably all muted. So if you want to say something, you need to unmute yourself.
Rabbi, I think that was a great talk.
Thank you.
Somebody early on mentioned something about the universe, and it's just astounding to me that if I got in a spaceship and went in X direction, I can find myself within the proximity of a neutron star, which is about the size of Manhattan, rotating around like 100 times a second. So that's kind of scary. You mentioned about the uncertainty principle. As a chemist, we talk about the zero vibrational energy, so that even when a particle or whatever is at absolute zero, which is absolute zero, there's still uncertainty in it because of this 0 point vibrational energy. And in fact, in very deep time, it's like a trillion to the power of a trillion to the power of a trillion to etc. That the density of the universe will become uniform and everything will just be black with like a hydrogen atom every so often.
Yeah, so yeah, the question,
So
which
it's a
is not
matter of
something,
timing
yes,
with regard to whether it's completely just a hydrogen mist.
right. One, I see my friend Robert Piccioni on the screen. Hi, Robert. I don't know if you were able to hear me quoting you and your books, and I don't know if you have anything that you would like to add. You need to unmute.
Did I unmute?
Yes, you did.
Okay, good. Let me just add a word about the origin of life. I'd like to make a clear distinction between the origin of the first life and evolution. So I think evolution is a wonderful theory. It explains how life evolves from generation to generation. And I fully believe that it could create what we see today by a relatively modest rate of progression. I think if you add one complete nucleotide base pair every generation from the beginning of time till now, you could end up with a human being. I think that's mathematically viable.
Mm-hmm.
The other side is quite different. The origin of the first life, you can't really invoke Darwin because there's nothing to evolve from. And so the position of science, the default position without giving it a lot of thought, is that the first life must have, its DNA must have evolved through some random chemical process. And what I do in my book is I calculate the probability that that could happen in a way that produces the simplest possible form of life anywhere in the universe throughout, anywhere in the observable universe throughout its entire history. And that's the number that I calculate. And as you said, it's as unlikely as drawing the ace of spades consecutively 119,000 times. Or if you prefer, the odds of that happening by random chance are 1 in a number n, and n is a number that has 230,000 digits.
Ah, that was the one I was looking for. I
So
didn't even know how to
that's enough
begin.
digits to
So
fill
it's 10 to the 230,000.
Yes. So that, I think, is far beyond any reasonable estimation of what could have happened by random chance. So I calculate in my book how many carbon atoms there are in the observable universe, how many amino acid nucleotide base pairs that could possibly have formed, how often these nucleotide base pairs could possibly have interacted with one another. I assume every point in the entire universe is completely habitable, which obviously doesn't make any sense, but that's an upper limit. And I find that the number of combinations of DNA that could have been explored in the entire history of the universe is a number that has 102 digits.
Mm-hmm.
Well, 102 digits is a trivially small number compared to a number that has 230,000 digits.
Yes.
So this notion that science has long maintained that given enough time, it must happen eventually, that isn't a quantitative argument. And if you look at the actual numbers, it is completely irrational. The notion that life could have evolved through any currently known chemical or physical process is absurdly small. Anything else, any other proposal has to be at least as likely as that.
And I would add to that, one of the things I'll get to at the very end of this presentation is, what are the consequences of making these kinds of assumptions? Are we hurt? Are we helped? That's actually going to be my bottom line, a week from tonight. I actually want to read, before I stop recording, another quote from this book by Rabbi Jonathan Sachs, The Great Partnership. This is following up on his quote that I adore, which is, science takes things apart to see how they work. Religion puts things together to see what they mean. He says, science is about explanation. Religion is about meaning. Science analyzes, religion integrates. Science breaks things down to their component parts. Religion binds people together in relationships of trust. Science tells us what is. Religion tells us what ought to be. Science describes. Religion beckons, summons, calls. Science sees objects. Religion speaks to us as subjects. Science practices detachment. Religion is the art of attachment, self to self, soul to soul. Science sees the underlying order of the physical world. Religion hears the music beneath the noise. Science is the conquest of ignorance. Religion is the redemption of solitude. Reading his book, by the way, convinced me that I didn't need to write my own. Between him and you, Bob, I think you guys have it covered. So I'm going to end the recording, but I'm not going to rush off